Hey there, fellow Sipnians. Welcome to today's explainer. We're going to take some math concepts that might seem tricky and make them super simple and honestly pretty fun. If you're here for a review, you are in the exact right spot. We're going to treat this like a game, building up your confidence step by step until you've totally mastered these topics. Let's get right into it. So here's our game plan for today. First, we'll establish the golden rules. Then we hit the easy level to get our feet wet. Next, we level up to the medium level, and finally, we take on the boss fight, the hard level. We'll wrap things up with a quick outro and some independent practice. All right, let's kick things off with our intro and the golden rules. Okay, so our absolute core rule, pun definitely intended, for absolute value is this. It represents distance. And distance, it is always non-negative. I mean, think about it logically, right? You literally cannot walk -5 steps. So, because distance is always positive, whenever we solve an absolute value equation, we almost always have to split it into two separate paths, a positive case and a negative case. It's kind of like hitting a fork in the road. Now, when we shift over to inequalities, a massive pitfall for a lot of people is drawing the wrong type of boundary line. But the secret to getting it right, just look at how strict the symbol is. If it's a strict inequality, meaning it's just a less than or greater than sign, you're going to use a dashed line or a dashed parabola. That tells us points sitting exactly on that line aren't actually included. But if it's an inclusive inequality, the ones with that little equal to bar underneath, then you use a solid line or parabola. Pretty straightforward, right? Moving right along, let's jump into the easy level, the first step. Let's look at this equation right here. The absolute value of x minus 9 equals 7. Now, the absolutely crucial thing to remember is that we never, ever treat absolute value bars like regular parentheses. No way. We have to apply that golden rule we just talked about and split this equation into two distinct paths. So case 1 becomes x minus 9 equals 7, and case 2 becomes x minus 9 equals -7. To get x all by itself, we just use a really systematic addition step for both of these cases. Over in case 1, we add 9 to 7, and in case 2, we add 9 to -7. I know it might feel a bit tedious, but taking your time and thinking systematically like this completely prevents you from missing that negative root. Slow and steady definitely wins this race. And boom, there we have it. Level 1 cleared. We get x equals 16 and x equals 2. You systematically found both correct roots. Seriously, take a second to validate this. It's your first major win of the explainer. Awesome job. All right, now it's time to test those skills with checkpoint 1. What is the very first step in solving the absolute value of x minus 5 equals 10? Go ahead and pause this explainer right now, think back to our golden rule, and lock in your answer for checkpoint 1 on your Google form. Welcome back. Let's keep the momentum going with checkpoint 2. Solve for x when the absolute value of x equals 9. Take a quick moment, apply that splitting rule, and select your answer. Ready for more? Let's level up to the medium level. Second step. Okay, so sometimes absolute value equations need a little bit of cleanup first. Here is the strict chronological order you absolutely need to follow when the absolute value isn't sitting all by itself on one side of the equal sign yet. Step 1, isolate the absolute value. Step 2, split it into two equations. And step 3, solve for x. You really got to follow these exact steps in this exact order to nail this. Let's conquer this one together. We have the absolute value of 2x plus 5 plus 8 equals 23. Step 1 is isolating that absolute value, right? So we subtract 8 from 23, which gives us 15. Now we have the absolute value of 2x plus 5 equals 15. Then we split it. Path 1 is 2x plus 5 equals 15, and path 2 is 2x plus 5 equals -15. Oh, and a super important quick warning here. If your isolated absolute value ever equals a negative number, like, say, -166, it is a trick question. Remember, absolute distance literally cannot be negative, so if you see that, there's no solution. But for our current problem, we just solve both paths. And level 2 is cleared. We get x equals 5 and x equals -10. That is a solid medium-level challenge down, and you are leveling up fast. Let's test that brain power again with checkpoint 3. Look at the inequality y is strictly greater than 3x plus 2. Based on phase 1, what kind of boundary line should be used here? Hit pause and lock in your answer now. Moving right along to checkpoint 4, I want you to solve the absolute value of 3x minus 6 equals 18. Grab a piece of paper, work through the algebra carefully, and pick the correct roots. And here's checkpoint 5. What is the solution to the absolute value of x plus 56 equals negative 156? Now, I'm going to give you a heavy hint here. Think back to what we just talked about regarding the impossible scenario of absolute distance equaling a negative number. Go ahead and tackle that one.
All right, it is boss time. Welcome to the hard level final challenge.
Here's our final boss problem. The absolute value of x squared plus 9x plus 14 equals 0. Now, because this equation equals exactly 0, and 0 doesn't have a positive or negative version, it's just 0, we actually get a sweet shortcut. We get to completely bypass the usual splitting rule. There is only one single case we need to solve. So we just solved x squared plus 9x plus 14 equals 0. Step 1 is to gently break down that factoring process. It factors out into x plus 7 times x plus 2 equals 0. Step 2, we just solve those two binomials to get our final roots, which are x equals negative 7 and x equals negative 2. And just like that, you've took down the quadratic boss without breaking a sweat. Before we head to your final test, let's do a quick pivot back to our other core topic, inequalities. Whenever you need to figure out which side of a boundary to shade for inequality regions, just pick a test point. The origin, 0, 0, is usually your best friend here because it's so incredibly easy to calculate. You just plug it into the inequality. If the math checks out and the statement is true, you shade that side. It is literally as simple as that.
All right, you are fully equipped and ready for this. I want you to take a deep breath, pause this explainer, and finish really strong by answering checkpoints 6, 7, 8, and 9. They're all grouped together in your Google Forms. You've totally got this.
Finally, let's wrap up with our outro and independent practice.
To really lock down everything we've learned today, I want you to tackle the independent practice questions below. You guys did amazing work today conquering both linear and quadratic absolute values. But it really begs a wild question. What do you think happens to all our rules when an equation has an absolute value inside another absolute value? Think about that. Keep practicing, stay curious, remember that every mistake is just a step closer to the right answer, and I'll see you in the next explainer.